one of these applied situations, right? And this is where vocabulary starts being added in. So I've simplified a situation. I've got a wall, I've got the floor, and I've got a ladder leaning against the wall. Okay? And you will notice that what has that situation set up?
A triangle.
A triangle. It's a right angled triangle, isn't it? Okay? We have to simplify the situation because we assume that the floor is perfectly flat and we assume that the wall is perfectly perpendicular to the floor. We do live in Bermuda with lots of old dodgy houses, so you'll know that that's not necessarily the truth. So this is a situation where it's a model of a situation in ideal circumstances. All right. So there are certain things that we can work out. So we can work out the height up the wall. So if I were to ask you to work out how far up the wall the ladder reaches, all right. Now I haven't given you any numbers at the moment, so we can't actually work these things out. But these are the kind of things that could be asked for, given certain numbers. I could ask you for the height up the wall. Okay. I could ask you for the distance of the foot of the ladder from the wall. Okay? Where's your feet? Yeah? The foot of the ladder. But again, this is the kind of vocabulary that does come up. So it can be, although it's an international GCSE, it can be a bit English at times. You know? The foot of the ladder from the wall. We could also say what angle does the ladder make with the wall or floor? Okay. So what do I normally know? Well, I normally know that a ladder is, say, 3 meters. Well, the floor, from here to here is about 3 meters.
Yeah, that's not
floor to
small.
ceiling, that's not.
Oh yeah, that is small.
All right. So actually, that normal, quite big ladder. What I could, other information I could give you. So what I would like to know, I'm going to say to you that this ladder is,
X.
what should we say, 1.5 meters from the wall. So the question that I would like to answer first is, what angle does the ladder make with the floor? And how would I do that? Right?
Okay, so not the 90 degrees, but the other one. Yeah, that came
So this is the angle
yeah.
that I'm talking about. This is
So-
the angle that the ladder makes with the floor. So I'm going to call that theta.
Okay, so
So
the wall is opposite of.
okay, can I do SOHCAHTOA?
Yeah.
Right, how do I know I'm going to be doing SOHCAHTOA?
Trigonometry.
Layla?
Because you're looking for theta.
I'm looking for the angle, yeah, I'm looking for theta. Alright, so I've got a right angle triangle and I'm going to be using, I'm trying to find an angle. If I was trying to find the height up the wall, I could just use Pythagoras' theorem because I'm not using an angle and I don't need to know the angle. I've got 2 sides I need to know. So I could use Pythagoras with this question as well. But I need to know an angle, so I'm going to use trigonometry. So I think, as you were saying, if I label these, this side here is the,
Opposite.
that's the opposite.
3 meters is the hypotenuse.
This is the hypotenuse.
Yeah, 1.5 meters adjacent.
That's
to
the adjacent, so from here to here.
So we're
Okay.
gonna be using cos.
Okay, so I'm going to write,
That.
sorry, let me give myself some space. Theta opposite adjacent hypotenuse. Again, do or don't, up to you. Theta is what I want to know. Call it x if you like. The opposite side, I don't know,
Don't care.
don't care. The adjacent side is 1.5 and the hypotenuse is 3. Okay, so anything with an O in it,
We cross out.
cross out. So I know I'm using cos of theta equals
1.5 over 3.
Adjacent.
1.5 over 3.
And then you do theta.
So do you remember what we said? Just to recap, and for Jasmine, cos theta is just a number. Okay, so I'm not dividing by cos or anything like that, but to know the angle, I do have to do the inverse to get the angle back from that number. So to work out theta, I am actually going to do the inverse cos on this number that's 1.5 over 3. Which you're going to use your
Equals 60.
every single time we do an angle. we
Yeah.
do the inverse.
It will be.
Maybe that's why it looks so.
It equals 60.
60.
Yeah.
Yeah.
Everyone agree? 60 degrees. Now, does that make sense?
No.
What?
60.
It's less than 90.
It's an acute angle, so it would be less than
But the actual value of 60 degrees.
Is
What do you notice, like, if I were to just happen to...
Hey, it's the 111 or it's the 22.
It's close, isn't it? If I did exactly the same the other side, what do you know?
It's 22.
So that's 1.5, that's 1.5, that's 3. We actually have a 3, 3, 3. It's a equilateral triangle. So it makes sense that this is a 60 degree angle, and this one up here would therefore be a 30 degree. So
On the other side.
that makes sense. Now, that just happens because of the numbers I picked. It doesn't.
Oh, so if it's half, if the bottom is half.
If the bottom is half of the hypotenuse,
And it's a right angle.
and it's a right angle triangle, we
It'll be 60.
okay. So that's how we're using trigonometry. Are you okay with that, Mo? Yeah.
Wait, so when finding the angle, you're doing an inverse?
Yeah. So for
So
instance,
what's the opposite of inverse again?
just doing sine or
A regular
cosine.
Okay, because I just did all that for this working out.
Okay. So let me just check then before I ask you the other stuff. Right. So here's a triangle. It doesn't look right angled, but I've done what symbol, so I know it is. Let's say I'm asking to find. That's a different symbol also used for angles. Okay. Let's say I'm telling you that that is 3.4
What's it called?
and this is 5.8. What's that one called? Is it a phi? Don't know.
Oh.
Might be. Right, so everyone, have a look. We've got to find the angle. How do I find the angle of this triangle? Later?
You just do what we did again to the right side.
Okay, so I'm going to do SOHCAHTOA,
And then you know that
theta opposite adjacent hypotenuse. Theta is
F.
that one. Yeah,
Wait, what does that say?
we were just talking about this. I don't know actually. I'd have to look it up.
Can I look it up?
Well, not now because I want to solve this.
Okay, so, and then opposite would be 5.8.
5.8.
And then that would be 3.4.
This would be 3.4.
And we don't need 8. So
Okay.
that we get rid of all the ones with H in it, so it would be 10.
So we then have tan
Theta
equals.
3.4. I mean 5.8 over 3.4.
So if I want to know the angle,
We do 10 minus 1,
If not 1
and then 5.8 over 3.
And that equals 59.6 degrees.
now do you remember we said before that the ratios couldn't be more than 1 unless it was tan? Tangent deals with the opposite and adjacent sides. If the hypotenuse is involved, it can't be. Alright?
You have to do 10 minus 1.
You know what's coming?
No.
The test.
No. Not really a test, is it? It's a question of
Oh.
what are those two triangles?
I can do it. Can I keep doing this first? What?
I'm going to go Gabriella because she's put her hand up for the first time this lesson. So.
Okay. So the first one is I want to do right angle.
So you want to do the right angle triangle.
Yeah.
Okay.
And then
Go on.
the bottom one is 1, and the other one is 1. And then it's 45 degrees. And then the top one is 45 degrees. And then the length of the hypotenuse is root 2.
Thank you. Root 2. Good. Happy with that?
Yes.
Well memorised. Good. Haley.
Okay, the next one's an equilateral triangle with all the sides is 2. And then the height is
Hang on. So we've got 2, 2, 2.
root,
And then we want to do the height of that triangle. Excuse my diagram. I can see it on this screen, doesn't it?
root 3.
So the height is root 3.
And all the angles are 60,
So that's 60. That would be
30,
30.
overall 60.
Okay. This is the right angle triangle. I'm only labelling one side for a reason. Okay. Can you see we just had that situation? The hypotenuse is 2. This bit is actually 1. So it's half. So we've got that situation. Okay. So I said to you, we memorise these triangles. We can now do sine, cosine and tangent of certain values without needing our calculator. Any ideas already? Jet?
I'll do the left one. If it's okay, no, I'll do the right one. So say like all the legs are 3.
They're not. They're 1s and 2s.
Oh, but can you change it and then it would be never mind.
If you change it to 3s and things, you've then got to simplify your answer. So this is in simplest form if we can get this right at this stage.
Okay.
What are you asking us to do?
I'm asking you to tell me sine or cosine or tangent of a particular angle and give me an actual value. So let me explain, right, rather than let's guess. So for instance, I'm telling you, if I want to know the sine of 48 degrees, that's the ratio of sides of a triangle with a 48 degree angle, yeah? So remember, that's what that number is. It's a ratio, and then you can find any infinite number of sides combinations as long as the ratio is whatever that is. What is the ratio for sine of 48? The fact that none of you have reached for your calculator means you either have no idea what I'm asking you for, or you just wait for me to say the answer. I don't know. You need to get your calculator and work it out. Division. So what's the sine of 48 degrees?
0.743.
Okay, do you remember how we started this? Was if sine of 48 degrees is 0.74, that means the opposite side and the hypotenuse have to be in the ratio of 0.74 degrees. Okay, which means that the opposite side could be 74 and the hypotenuse would be 100.
Oh.
74 over 100 gives me 0.74. We had roughly. So I need to know that. Therefore, I can find any combination as long as they're in that ratio. I can't work out that ratio in my head though. I need my calculator to tell me what the ratio of sine of 48 is. Alright? Got that? Like sine of 68. Like sine of 132. Like sine of 7. All these are values that I have to have my calculator to work out. The cosine of 1.3. I don't know, I have no idea. Alright? However, there are certain values that I can be expected in an exam to not need my calculator to find. The clue is on the board. The clue is the fact that we have some angles here that are 45, 60 and 30. So, for instance, I can tell you that the tangent of 45 degrees is equal to 1. You can try it on your calculator if you like. Why can I tell you that? Hayden?
Because the side is 1, and then I don't know how that would link, but if
What's the ratio for tangent?
45 to 1.
No, how do we say it? Sokotoa. Toa means?
Oh, it's because those sides will always be the same.
So Sokotoa, okay? Tangent is opposite over adjacent. Of this triangle with a 45 degrees, what's the opposite?
1 over
1.
1 and 1. Now, if I extend that triangle to have 45 degrees, it has to be the same and the same. Therefore, the ratio will always be 1. If it's 2 and 2, 3 and 3, 5 and 5, that's the only way to get 45 degrees, right? If the two sides are the same. So it has to be, the ratio has to be 1. Now, I'm not telling you that the sides of every triangle have to be 1 and 1, but I'm telling you that the ratio, the tangent of 45 degrees is 1. Alright? Jen?
For that triangle, is cos of 60 0.5?
Yes.
1 over 2, yes. Yeah? Understand why?
That's why.
Because cos is
Oh no, wait.
adjacent over hypotenuse. What's the adjacent to the 60 degree?
1.
1. Hypotenuse is 2. So what's the sine of 60?
It'd be square root of 0.2.
0.866.
You've used your calculator. I don't need. Look, everyone that's just looking, it's actually root 3 over 2. Yeah? Is that right? Because sine is opposite over hypotenuse. Yeah? So what about cos of 30?
3 over 2.
Root 3 over 2. Sine of 30.
1 over
2 again.
Oh, I was looking at that.
Yeah. Alright. What is therefore the tangent of 60?
root 3
Root 3.
over 2.
Nope.
Never over 1.
Remember, we're only using the half, so root 3 over 1 or just root 3. What's the tangent of 30?
No.
1 over root 3.
1 over root 3. Okay. What's the cosine of 45? 1 over root 2. What's the sine of 45?
No. 1 over
1 over root 2 again. Okay? Right? So here's the thing. Those values, there's two ways I could have approached this. We could have written them out and gone, you have to memorise them. Okay? So I have to memorise that tan of 45 is 1, cos of 45 is 1 over root 2, and so on. Okay? Because these are ones that you're expected to be able to solve without using a calculator. Okay, certain ratios. So I now know, for instance, that a triangle with an angle of 60, the ratio of opposite to hypotenuse is root 3 over 2. So I just have to multiply root 3 over 2, top and bottom, by a number, and I will get a triangle with a 60-degree angle. That makes sense. So 2 root 3 over 4 would be a triangle with an angle of 60. Alright? So we could try and memorise all those. I prefer memorising the triangles. It just seems a bit easier. And then being able to work out all the ratios, and we're just applying the things. Because the reason why, quite often they'll give you an exam question, and it's a bit kind of a roundabout way of just getting you to do this and just applying the ratios, but it's not obvious necessarily that that's what you're being asked to do. You might be given the ratio and asked to find something. I don't know how to do it. Right? So these are values that you ought to be able to remember. So let's just check whether we can, for instance. So if I were to say to you, no calculators allowed, okay, here is a triangle, alright, let's just say that that's the 90, that is 60 degrees, okay, and I say this side here is 10. What would that side be?
Is there
No
any
calculator.
So what angle 5?
Wait, no, 10.
Why 10?
No, it would be 5.
So what ratio am I using to solve this?
Half.
Now what ratio am I going to use? So don't forget what you've been doing. So we do SOHCAHTOA.
It would
Right.
be cost.
This time we just have to do it without a calculator. So I would do opposite, adjacent, hypotenuse and theta. Theta I know is 60. Opposite is, don't know. The adjacent is x. The hypotenuse is 10. So I now know that I'm using cos, right? So cos of 60 equals x over 10. Okay. So how would I now find x? So it'd be 10 times cos 60 equals x. I'm not allowed my calculator. Stop using it.
Sorry.
Alright? So how do I know what 10 times cos of 60 would be? Because I know that cos of 60 is what? So with my triangle, I'll be like 60, that means it's a 1, a root 3 and a 2. That's the 60. So cos of 60 is adjacent over hypotenuse. So I actually know that's a half. So therefore this would be 10 times a half, which is 5. So I know x equals 5.
Also, you could if you see the triangle, it's like half of an equal.
We know that as well, don't
But
we?
it's not always drawn the same.
But can
Yeah,
you
but
see,
degrees.
like our first statement that we made about the triangle with 60 degrees, remember we started with, oh, if it's 60 degrees,
They're all 60.
the adjacent side is half the hypotenuse. And we've added kind of evidence to the fact that we've done cos of 60 is a half. The adjacent over the hypotenuse is a half. Right? So you now know that if I know the hypotenuse and I know the angle is 60, the adjacent side would be half of it. Alright? Not so easy would be this one. So what would I do if I was to use trigonometry? Because I don't need to now, do I? I could use Pythagoras' theorem to work this out. But let's say I was going to use trigonometry to find this one.
Well, I want the hypotenuse. No, I want
So this one would now, I'd be using, so sine of 60 equals, let's call this y, y over 10. So this time I've got 10 times the sine of 60 is y. What's the sine of 60 this time?
root 3 over 2.
So sine of 60 is root 3 over 2. So then I've got 10 times root 3 over 2 is y. So this is a bit different. It's not quite as easy, but still, because you've done thirds, actually really easy. Because it's what? 10 times root 3 then divided by 2 is the same as 5 root 3.
What?
Because
There
it's
is.
all on top.
Yeah. You times and divide, you can do it any order. And that means that length is, in exact figures, 5 root 3. No longer do I need to put it all in decimals and things.
Yeah, 75.
Okay?
It's
So,
75.
there are these values that we're expected to be able to use and remember and work out triangles without needing to use our calculator. Yes?
This may be like a weird question, but will there
I don't
ever
think
be
it should.
trigonometry questions that don't have a right angle in the triangle?
Yes.
How will we work that? Will we
You'll
put
have
in a
new
height?
things called, no, we've got 2 new rules called sine, shh. Kiara, stop talking over me. Thank you. Just wanted to put that on video. Yes, if it's not a right angled triangle, we can still solve it, and that's what we would move on to. A couple of lessons time, and you're going to have to do that in the end of year exam, and they're called sine rule and cosine rule. Now they have their basis in right angled triangles, but it's like an extension. It's how do you use them to solve for non-right angled triangles. Well, it's actually a rule. You can look them up. Sine, it's a relationship. They're a bit more complicated. I don't want to write them up now. Feel free to go and research them, but we will be doing them. But so what I should be able to do at any stage now is give you a little quiz on solving some certain triangles without a calculator. Yeah, I'm not going to do it tomorrow, am I? You've got a test tomorrow, as you say. I'm just saying I should be able to. Whether I do or not is a different matter. Yes?
I think your question about the exam at the end of the lesson.
Well, it's kind of now.
Oh, okay. So will we be
Shall I? It's not.